Okay, and thank you everyone for joining us to the next session of JNation, right? So in here I have really pleasure to have Johan with me. Hey Johan, how's it going?
Hey, I'm doing great. How about you?
I'm okay, thank you so much. I mean, really pleasure to have you here with us. I know that we wanted you to speak at the conference for so long, and finally we can make it happen. Too bad we cannot make it in person here in Portugal. Maybe we can do it next year, hopefully.
Yes.
Uh, we'll love to host you. Um, so anyway, I know they're going to talk us a little bit about Java 16 and 17, which is like very exciting. Like the new, so 16 already came out. People are expecting 17. Are you ready using 16 and 17?
Yes, we're basically transforming as we speak to 17.
Cool. So I hope that you can share some of that knowledge with our audience. So without any further delays, I mean, the stage is yours. So feel free to move.
Okay, cool. Thank you. Let's share my screen. So basically, we're going to talk on how and why to upgrade to Java 16 or 17. As said, my name is Johan Janssen. I work for Sanoma Learning. And let's move to the next slide. So short the agenda, basically we first cover why you should actually upgrade and then move on to actual steps that you need to take while upgrading and give you some tips and tricks on what you can expect when upgrading. So it hopefully is easier for you to do. If you have any questions, you can ask them later or during the session, and Roberto can interrupt me if he wants, or afterwards. It's also possible to contact me. I also gave Roberto a list with the links, which are quite interesting, which are sometimes also shown on the slides, but you can find them in the Slack later as well. I created a GitHub page, which basically is the basis for this talk, which contains a lot of information. I can quickly show that one as well. So it shows background information, but also like what's changed in which Java version, what errors do you get when you still use it, and how can you fix it. So that's basically also what we will cover in this talk. And so that can help you as a nice reference material, and it's still being updated as we're currently moving towards Java 17 as well. A little bit of background. I didn't get all this knowledge by Googling a lot. I've been upgrading Java for many years to Java 8, to Java 11, and upgrading frameworks and stuff like that for years. Still Googling a lot, as everyone, of course, if you find any errors. But that's a bit about my background and where this talk came from. We are currently in the process of upgrading everything to 17, so that as soon as it's being released, we can actually start running our applications on Java 17. Why then should you upgrade? There are quite some good reasons for that. For instance, free performance improvements, but also security fixes and bug fixes. But I think for developers, it's also nice because you can use the new features such as records, pattern matching, and all kinds of nice things in the new Java versions. And I think in this time where it's quite hard to keep and attract developers, for a company, it's also interesting to upgrade because then they can offer developers new and exciting technologies. I also sometimes get the question, yeah, why should I upgrade? It's really a lot of work, and yeah, of course it can take a bit of work. But I think most people are a bit afraid about Java 9, the module system, or Jigsaw, because people think that you need to incorporate that into your application. And that's actually not true. You can perfectly upgrade to Java 9 without rebuilding your application with the module system. That still works, and I think that's what like 95% of all the projects are doing on this moment. So you don't have to be afraid for that. It goes relatively easily. Some companies, of course, also create applications that run not within the company, but on customer hardware. And then sometimes it is a bit harder to upgrade that because your customer needs to upgrade those machines, actually. For that, there is maybe a little bit of an idea. At least I know that a lot of people aren't aware of it, so I thought it would be good to mention it in this talk. So nowadays, with the multi-release jar feature in Java, you can actually have multiple versions of Java inside one jar file. So in this example, we have an application file in the Java.com example directory and a student file. Next to that, we have a Java 17 folder, which also contains a student file. But let's see how that works in an editor. So I have an application file, which basically retrieves the Java version this is being run in, some information from the student, and it checks whether two example students contain a blank in their name. Then we have a student class, which is probably quite familiar. It's a class file. I implemented a isBlank method where I need some checks for to implement that. I return some info that this is a Java class, and that's basically it. Then we look at Java 17. What you notice immediately is that this is not a class, but a record. So it's a new Java feature. And one of the other new Java feature is the string.isBlank method, which basically does the same thing as the method I implemented for the older Java versions. And here I return that this is a Java record. I also need to configure some stuff in this case in Maven. So I say that the normal code in the source main Java directory should be compiled with Java 8. And I have some other code, the stuff in the Java 17 directory, which should be compiled with Java 17. I also have a little bit of configuration to say that my main class is the application class, but that's not really release specific. And then I created a Docker file, which basically starts by using a Maven on Java 17. It will then package the application and run the application. Next, we will use that same jar file, but then we will run it on Java 8. And in the last step, we will do the same, but then on Java 11. Now, if you execute this, yes, this one. It will basically execute all the steps one by one. And if we scroll up a little bit, so we see here Java 17 is being used, the record implementation is being used, and the two checks are being done for the isBlank. In Java 8, we see that the Java class is being used, and again, the checks. Java 11, we also see that the Java class is being used and the two checks. So basically, on Java 17 or higher, the code in the Java 17 directory is being used, and for the older versions, the code in the Java directory is being used. And so you can use that, for instance, if there are some performance benefits in a new version of Java, some methods that perform a lot better, you can basically create a version for that new version of Java, which then your customers can use if they have that new version of Java, and customers that don't have that new version of Java can still use the old version, which might perform a bit less. However, there are some things that you really need to keep in mind. So every version, in my case for the student, should implement the same public APIs, because else you of course can get runtime issues if you call methods on a Java version that don't exist in that Java version. Unfortunately, that's not yet enforced by build tools, so I can perfectly build it with Maven, where I have differences in the various implementations in the public API. Luckily, the IDE, at least IntelliJ in my case, gives a warning. And nowadays in Java 17, the jar tool is updated. So you can also use the jar -- validate to validate if your jar is indeed correctly implemented. So this might be a nice to, for some small parts. I wouldn't recommend like creating your complete code base in 3 different versions of Java, because that of course means that you have to test it and maintain it in 3 different versions of Java. So it's nice for maybe some small parts where you really want to use new APIs of the JDK. One thing that also, in our case at least, and I think a lot of companies are using it nowadays, makes it easier is the use of Docker. So before, when we upgraded Java, we had to upgrade the build environment, often a Jenkins machine or something like that. And later we needed to upgrade all the production environments, the development environments, the test environments and everything. That sometimes was even a manual task, sometimes automated. With Docker, that is a lot easier. Basically, in our case, the team can upgrade the Java version in their Docker file, and that's being used to build the application in the build pipeline for CI/CD. And we have Docker files to run the application, which the teams can also upgrade themselves. So every team can do this on their own pace. We don't need central machines to be upgraded. It's all abstracted away with Docker. So if you plan to regularly update your environments, I think an abstraction layer like Docker can help quite a lot with it. Yeah, so this session is basically there because a lot of applications are still on very old Java versions, 8 or even older. And a lot of people think that it's really hard to update it. And I fully agree that it's hard to estimate it because there are a lot of differences between projects. It really depends on what dependencies you're using and what plugins and stuff. Nonetheless, I've seen estimates for the migration from, for instance, Java 8 to 11, which ranged from weeks to months for one project, which was maintained by one team. Well, I actually managed to do that upgrade in a couple of days. And that partly was due to my experience with previous upgrades, but it's also because developers often really overestimate it. And then the business management decide to postpone it because they see it as too large of an investment. So I think it's also good to get a good view of what you really need to do and how much work it is to make sure that we can actually convince management and business to do these upgrades and stay on a current version of Java. So it is a bit of a challenge, but let's tackle that challenge. And what I've seen is that a lot of the things that I see in one project while upgrading it, they occur in the next project as well. So there's a large overlap of issues between the various projects. So what I hope to do here is share the common issues that you are probably going to get while upgrading. So you can easily solve them and focus on the maybe specific challenges that you then still have in your application. I use Maven as an example, but of course you can use Gradle or any other tools to do this as well. And so let's go on this journey together because hopefully that's more fun, and I really hope it saves you some time and make it quicker to migrate. One thing I think is interesting before you start with migrating is to think about where do you want to migrate to? Before we had a Java release every couple of years. Now we have a LTS, long-term support release every 3 years. We are on 11 now. In September 17 will be released. But in the meantime, there are a lot of other versions released from Java. Between 11 and 17, that was of course 12 to 16. Every 6 months we have a new release. I think the big change, the big difference between those releases is that an LTS version receives support and minor updates for a really long period of time, at least until the next LTS version. And depending on the vendor, which JDK you're using, it can be for an even longer period of time. While for the minor updates, most vendors stop support after 6 months. So you can no longer do a minor upgrade after 6 months. I've heard there are some vendors such as Zulu who actually provide support for those versions for a longer period of time, but in general, it's the LTS versions that are receiving minor updates for a longer period of time. So what to pick then, the minor upgrades or the major upgrades? We made the decision to still stay on the major updates because that make sure that we have some more time to upgrade. Minor updates are still being rolled out. We don't run the risk of being on a version that's no longer supported. However, I can imagine that for us that might change if, for instance, Java 18 introduces some really cool features. We might then see if we can change that decision again. But for now, we think that it is quite some hassle for our teams to every 6 months do an upgrade, and we're not sure if they get the time to do that from management and the business. So that's why we play it safe for now, but evaluate at a later point if that's a good decision. So when you upgrade, what do you actually have to upgrade? In general, an application consists of some code that you've written yourself, some dependencies, and it all runs on Java, on a JDK. Now, in a new version of the JDK, something can be removed, and then you need to change something in your application code, in your dependencies, or maybe even both. There it can really pay off to sometimes have a little bit of patience. If you wait for a little while, then hopefully the dependencies already have released new versions which are compatible with the latest version of Java. And actually, when we say deleted in the JDK, in general, stuff isn't deleted immediately inside the JDK. It's first marked for deprecation, and at a later stage, it's being deleted. So if we look at an example, for instance, JuxB, it was a normal feature in Java 8. After that, it was deprecated for 2 versions. So when you upgraded to Java 9, you already got a nice warning that you should do something. And if you then already resolved the issue, then by the time it was actually removed in 11, you were already done with it. So it's a nice notification mechanism to notify you that you need to take some action, and then you have basically enough time to do that. So what can be removed inside a JDK? That's basically almost anything. Probably you're familiar with methods and things being removed, but even garbage collectors or encryption algorithms and stuff like that can be removed as well. So it's almost anything. If you want to see in detail like what's being removed, you can look at the Java almanac.io or the FUJ version of the Java almanac.io. It contains a detailed website on everything that changed in the APIs. So you can see which methods are being added, deleted, or marked for deprecation. So that's really interesting. I wouldn't recommend it as reading it through from start to finish, because that might be a bit boring. But if you do an upgrade from one version to the other and you get some compile errors because methods are missing, this might be helpful to figure out what happened to those methods and if there is an alternative available for those methods. There is some more detailed release information available. On the OpenJDK website, there is a lot of information regarding the releases and what will be in those releases. And the Oracle release notes contain some more detail. So let's have a brief look at those as well. So if you look at the OpenJDK website, here we can see the various JEPs, the Java enhancement proposals, or basically the features being added in or removed in JDKs. They're all mentioned here, so you can click through and get some more information. So this is basically on a high level what's changed in a JDK version, and you can watch it for 16 or any other version as well, or simply change the number here. And then there is the Oracle release notes, and they contain quite a bit more detail. So we can see, for instance, what features are being removed. So here we see some things being removed, some flags that are being deprecated, certificates being removed. So a lot of detail and information in here as well. Again, I would use this as a reference. You don't need to read through all of this before upgrading. I actually read this only after I did most of my upgrades already, basically. Then when you upgrade an application, in general, I think upgrading an application goes relatively quickly, but it can be spread over maybe a longer period of time if you can't work on it continuously. And that is really helpful if you can have multiple JDKs running next to each other. One to do the upgrade to the new JDK, and one to run your existing application and maybe fix a bug or something like that. And there are some various ways to do that. You can either replace it, but that of course is quite a hassle. In case of Maven, you can use the Java home variable, which will be picked up by Maven to determine the JDK. There's the Maven toolchains. You can also use SDKmon to configure your JDK, or Docker. I use Docker in my examples also because it's really easy. People don't need to install various Java versions, and you know for sure that you have a clean environment and not some configuration laying around which is specific for your machine. The feedback loop, however, is a bit longer, of course, because you first need to create the Docker image and then run it, and only after that you get feedback if something is working or not. So I wouldn't use Docker for like the actual migration, but to later test if indeed everything is working, or to create small examples and test if they are working on various Java versions is really helpful. It helped me to create some small examples of dependencies I was using, which broke in a certain version of Java. And then I could share that with the maintainers so that they had a concrete example and a way to easily run those examples. So in my case, I use a Docker file based on Maven and Java 17 or some other Java versions as well. I add the code, and then I basically run the tests, and I keep running until the end. I don't stop at the first failed test. So you can change that as well if you want. To execute those steps, we have to say docker build -t. We give it a name, in this case Java upgrade, and we specify the dot. The dot is important, don't forget that one. It's used for the context of Docker. Without it, it won't work. Then when we roll out a new Java version, I think the most logical steps is to start with your local machine, make sure everything runs there, then on the build environment, and as the last step on the deploy environment. I have to say I sometimes start on the build environment because I help other teams to migrate to Java 17, and sometimes it takes quite some work to set up everything on my local machine. So I start fiddling around on the build environment. But of course, that's a bit tricky if you want to quickly change something that's more difficult. So in general, I recommend starting on your laptop or desktop that you have. Then if you upgrade, I already mentioned you can upgrade from one LTS to another LTS, or you can also go to the minor versions. I would recommend when upgrading to not go from like 8 to 17, because if you have an issue, it's like finding a needle in a haystack. You don't know which Java version caused the issue. Well, if you migrate from one version to the other, you know which Java version caused the issue, so you can use that version with the stack trace or error you got and Google for it. And that's often a lot easier than only like an error. So I can recommend, if you have a lot of issues, try to do it step by step, the upgrade process. So let's look at the ingredients. First of all, of course, you should have an IDE with support for the Java version you're upgrading to. Doesn't have to be full support. I'm upgrading now to Java 17, which isn't like full supported, but I can do most of my checks well in the IDE. Nicest, of course, would be if it is fully supported, then you have all the support and you can do some refactorings as well. Then don't forget to upgrade build tools and plugins as well. Make sure you have a recent compiler plugin, for instance, for Maven, so that Java 17 is actually used and not underwater some older version of Java is being used. So we configure the Maven compiler plugin with the release, in this case, release 17. Then I always recommend to start with upgrading your dependencies. Probably it's best to do that on the old version of Java. First upgrade all the dependencies, check if your application still works, and then upgrade to the newer version of Java. In general, you need to update dependencies anyhow on a new version of Java, because sometimes some things break in the new version of Java, and new versions of the dependencies often solve those issues. Make sure to also check for new artifact and group names, but we'll come back to that in a later stage as well. If you want to figure out if there's a new version available for your dependency, you can use a Maven or Gradle versions plugin and basically execute these commands, and it will give you a list of all your dependencies and what the latest version is that is available. So that makes the upgrade process a bit easier, and your IDE, of course, also helps you with that. Then for the steps, I encourage to do everything like in small steps, so that you can show progress not only for yourself but also for, again, the business and management, to show that you're making steps towards the goal, instead of having to say, I think I'm 80% done, but I actually haven't finished anything yet. It helps if you first start with like compiling the source code. If you have that running, then you go to running the unit tests, or maybe before compiling the unit tests, and packaging the application, and in the end, test the running application. Again, doing everything step by step. And then if you're lucky, everything succeeds as promised, you have a nice pizza. But sometimes theory differs from practice. I've sometimes had dependencies that I tried to update on the old version of Java, but the dependency required a newer version of Java. Then, of course, you have to shuffle a bit in the ideal way of working, so to say. But let's look at some concrete things that have changed in the JDK. So Java 11, I think, was one of the bigger ones with a lot of changes that impacted quite a lot of applications. First, JavaVex was removed, but you can still download it as a separate build from Gluon. And what's also interesting is that JavaVex is removed from the specification and from like OpenJDK, but there are also vendors that create JDKs that contain more tools than just what's in the specification. In case of OpenJFX, there are Liberica JDK, which has a full build, and the OJDK build. They both contain OpenJFX out of the box in those builds, so you can use them as well, or simply use a Maven dependency for it. One thing that changed as well, where a colleague of mine had some issues with, was that some JDK fonts were removed. So previously, the JDK contained like a few fonts, only a really small set. So those fonts could be used in the application, for instance, by Apache Poi. Apache Poi can work with Office documents like Excel and Word. And apparently Apache Poi uses those fonts inside the JDK. However, they're no longer there. So now you have to use the fonts of your operating system. In case your operating system doesn't offer any fonts, then of course you will get an error. And you can resolve that by installing the fonts on your operating system. Java Mission Control was also removed. Java Mission Control is like a profiling tool and a monitoring tool for your application. If you haven't checked it out, I can really recommend it. It works really well to do all kinds of profiling and get detailed insights inside your application. And it's still available now under the new name JDK Mission Control through Adopt OpenJDK and Oracle. So you can download it as a separate tool. Then I think the change that impacts almost any application is the removal of the Java EE and Corba modules. And so Java EE, packages like JuxB, they basically are removed from the JDK, and you now need to use dependencies instead. And what you have to keep in mind there is what I mentioned briefly before, is that if you use new versions of dependencies, also check if the naming of the dependency hasn't changed. In the case of JuxB, it was previously known as a JavaX group ID, and nowadays it's a Jakarta group ID. So make sure that you are not only on the latest version of a dependency, but also that you check if the dependency didn't get a new name in the meanwhile. To make sure that you use the correct things in Java 11 and newer, you have to change the import because the naming has changed from JavaX to Jakarta, and you need to add the dependencies. By the way, if you want to figure out if the group IDs have changed, there are actually some nice plugins available for Maven and Gradle, which can help you to detect these kinds of issues. If we then look at what's removed from Java 11, we see a lot of things apart from the JuxB. Most of them got official replacements, except for Corba, which doesn't have an official replacement, but there is a Glassfish Corba implementation that you can use. So basically here, the column on the right is the most interesting one. Those are the dependencies that you need to add to your application if you use one of the modules on the left. In case of JuxB and JuxWS, you need to make sure that you include the dependency for both the API and for the implementation. That's why there are two mentioned for those two. For Java 15, there was one big change, and that was the removal of the Nashorn JavaScript engine. Before you could easily use Nashorn to do that. Nowadays, it's still relatively easy. You just have to add a dependency to it, and you can still keep using Nashorn. With Java 16, they worked on encapsulating the internals of the JDK even more. What's meant by that? It's basically internal APIs created by the JDK developers in the past, which basically weren't meant for normal customers, normal developers to be used. They were only meant to be used by other APIs inside the JDK. However, in the past, they couldn't really hide those. Only with the module system, they managed to better protect those, but there were still a lot of APIs available, internal JDK APIs, which aren't protected, and they are gradually making it harder and harder to use them, basically. Instead, you should use the higher level APIs, of course. In many cases, it's also a matter of upgrading dependencies. I had the issue of Lombok no longer working on Java 16 because of this change. However, within, I think it was 2 weeks or so after the release of Java 16, Lombok released a new version which resolved this issue. So if you're lucky, it's again waiting until there are some new dependency versions available and upgrade those. If that doesn't work, there is actually a way to work around it as well. So in case of Maven, we can specify some compiler arguments. And what we can do is basically we can say that we want to open up some internal stuff to the all unnamed module. So basically that means that all unnamed modules in your application can then use the internals specified in here. Of course, that feels a bit weird because it's like they put a lock on a door and you remove the lock and give everyone access. So I prefer to make sure that you upgrade either your dependencies, or if this is in your own code, make sure that you use other APIs of the JDK. For most scenarios, there are new higher level APIs available, so you should really use those and only use this workaround as a last resort. This is also where I can show how I try to use Maven toolchains, which is, I think, a more powerful concept where in the POM file I can specify on which Java version the project should be run. However, if I used it on Java 16, I got the following error, compilation failure, and that was it, which isn't really helpful, at least for me. It was a too brief error, basically. If I ran the exact same example directly on Java 16, then I got a better error. And basically it says that at the bottom, module JDK compiler does not export blah, blah, blah processing to the unnamed module. So that's basically what we did before. In the Maven compiler arguments, we opened up those parts again to the unnamed module. If this is resolved in the Maven toolchains, then I think toolchains is a really nice feature to, within Maven, run your application on various versions of the JDK. But for now, it wasn't really helpful for me when upgrading. Java 17, so relatively new, still in progress. The final set of features is now complete, and some changes were made that impact existing applications. Applet API, for instance, was removed. I thought nobody would use that by now, but I heard in a previous session that there are still some companies who use this with really old browser versions to make sure it still runs. So if you still use those, then yeah, you have a bit of a challenge. AOT and JIT compiler features have been removed. If you're interested in those, you can have a look at GraalVM. And the thing that will probably impact a lot of us again is strongly encapsulate JDK internals. So in 16, they already made a step. In 17, it becomes even stricter. So before we could use a launcher option, -- illegal access, to basically give access to everything again, but that no longer works. It's no longer being used, the launcher option. So that workaround is gone. The only fixes you have for that again is upgrade your dependencies, use the right JDK APIs, so no longer the JDK internal APIs, or again use the add opens, which still works, but yeah, it might be a question how long it takes before even that support is being removed. So I think it would be good to stop using that. I've used it as an example when I ran some tests and they still needed some access to some JDK internals. I configured Surefire, so it opened up some stuff. So it's still possible, but I really wouldn't recommend to still work around these kinds of things. Please simply fix it. Then there are still some open issues in Java 17. So I'm in the process of upgrading some applications to at least make them build. So I sometimes encounter issues, and this was one of the issues I encountered. If you have an enum with methods inside in this case, for instance, the test, then it doesn't work. So if I mock this one, I get an error like this. I created an issue for it. It's linked at the bottom as well. Actually, the maintainers already picked it up and fixed it on master, but it still needs to be released. But hopefully it will be there long before Java 17 is officially released. So basically, we're doing the groundwork so that hopefully you will have an easier migration later. One other thing that I encountered was in a project we were using Kotlin, and the Kotlin Maven plugin doesn't work yet. It also gives a quite clear error. It says that the supported version is only up until 16, and this was with the latest release candidate of Kotlin. So I'm not completely sure when to expect the new version of Kotlin that supports Java 17. For now, in our application, it seems that I can get around it by specifying Java 16 and compile the code to Java 16. That also looks to work, but of course, it would be nice if we can use Java 17 for this as well. Then in various versions of Java, so not only in 17, but in others as well, I got errors, for instance, with Jacoco. And then they say unsupported class file major version, and then some version is being noted. Same goes for some other things like the PyTest, the Spring Boot Maven plugin, older version. They also say that it's an unsupported class file major version. If you see that error, you have to remember that class file major version 61 is basically Java 17. So the error means that that dependency doesn't work on Java 17 yet. For every example I've shown before, it was simply a matter of upgrading the dependency or the plugin to the latest version, and then it worked. So it's basically a hint to, again, update your dependency if you haven't done so already. And so then basically we are finished. We've managed to resolve the issues, and I will quickly show you how my examples work as well, because that might help you to basically use it as a trial and error or as an example use case to show that some things break and some things work on a new version of Java. So in this case, I have the enum example of Java 17. I created a really simple test for that. And I can run some Java commands against that. Of course, first go to the right directory, that also helps. 18 almost, but not yet. And let's get the right Docker command. So I first run it on Java 16 to show you that it still works on Java 16. So let's quickly do that. My command is a bit more sophisticated than the one you saw in the slides. It's basically to cache some stuff. So hopefully this will go quickly and you don't have to wait for it. But in basis, it's the same. It's doing the same as the command I've shown in the slide deck. So here we see the test being run on Java 16 and everything succeeds. We now do the same on 17. We see that it breaks with some exception, that it couldn't modify some stuff. So this is the issue that I shown you. They are working on it and it should be fixed quickly. And I've made examples like this for the various versions of Java and for various features. So you can look into these examples to see basically what was the old situation, which breaks on a new version of Java, and how to resolve that with actual code examples. You can add your own examples if you want as well, and feel free to send me any pull requests if you want your example or have any improvements for the documentation or anything like that. So that's basically how the examples work. More information can also be found in the README on how to run the examples. And so basically we're done with like the hard and maybe a bit more annoying part, and that was upgrading the application. And now we can actually do the cool stuff. We can start using those new features like records and pattern matching and things like that. And maybe one good thing to note here is that I think in general, the upgrade from Java 8 to 11 is more work than the upgrade from 11 to 17, at least from my experience. Of course, it differs per project, but on the projects I migrated so far, it seems a bit easier. So that basically, I want to help you to not be too scared about upgrading to 17. It seems in general that it's relatively well doable. So I can really recommend you to start doing this. For me, I also had challenges convincing business and managers to do upgrades, and I simply sometimes on Friday afternoon after my hours were finished or nearly finished, I started running stuff on a new version of Java, see what broke, made some small fixes, see what broke then. Sometimes I already got quite far, and otherwise I had a relatively good impression on what went wrong and even could estimate a little bit better on how much time it would cost. So I really recommend to just get started with the upgrade process. Just do it and make sure you make small steps for basically your own motivation, but also for the motivation of others. That was it basically from my side. If you have any questions, feel free to ask them now, or if you have questions later, ask them later basically.
Hey, Johan. Yeah, that was a great presentation. Let me see if we have any questions for you. So let me have like a quick look here. I mean, there are some comments here, like people enjoying the presentation, but I don't see that we have any questions, I guess. Let me have a quick look. Yeah, so we have a couple of questions over here. So one is from which Java version the Docker is supported?
I at least from 8. I haven't tried it on an older version. I know that so some improvements in Java 11 were made to run more effectively memory-wise and things like that on Java 11, and those have been backported to Java 8. So if you use the latest minor version of Java 8, you should be good to run on Docker. That's no issue.
Okay, and we have another question here. So saying that, do you think that Java 16 or 17 is going to be Lombok's end or end of life?
That's an interesting question. I get a lot, and it's also something I encountered during all the upgrades, because most upgrades you need to do something with Lombok, else it breaks. Especially now the internals of the JDK are more and more locked away. I think it might partly be the end of Lombok, because we can use records for some cases, but keep in mind that records are immutable. So for things like JPA entities, you still cannot use records. So I don't think Lombok will go completely away. I think it will be there for smaller parts. At least that's what I think.
Okay. And I don't think we have any more questions. Those were it. So if there is any further questions, so please feel to reach Johan on Twitter. I'm pretty sure he'll be more than happy to answer any of that.
Yes.
Right?
Yes, of course.
Wonderful. Yes. So thank you so much for joining our session today, Johan. Um, hopefully we can see each other again anytime soon. And please stay safe.
Yeah, you too. Thanks everyone for attending, and have a good conference.
Yes, wonderful. Yes, so we're gonna have like a quick break. So the next session is gonna start by in 15 minutes. So you have more than time to go and go and drink some water, drink some coffee, maybe have some snack, and we'll be back. So the next session is also actually going to be coming from Josef Parmod and Maurice. The sisters from Flutter is going. They're going to talk a little bit of some of the new features coming in the new Java version. So I think it's going to line up nicely with what you just presented. Okay, see you in a while.
Bye.